Hi, you're welcome again to my grade advances, and you're welcome to our math mastery series. And in this series, I'll be teaching you standard form, your simple guide to dealing with large numbers and small numbers with ease. Okay, you always encounter problem in math, in physics, in chemistry, asking you to add numbers together in standard form, asking you to write numbers in standard form. Now, this lesson is actually going to help you to deal with these kinds of numbers with ease, right? Even if it's your daily problems you have and you're just thinking about how can you write this very big number? How can you write it in a more convenient way? If all of this is what you're looking for, you're challenged with dealing with standard forms, you don't know how to deal with it, you don't know how to add them, you don't know how to subtract them, you don't know how to multiply them, you don't know how to divide them, or even perform all of these operations together, this lesson is for you. I'm going to take it step by step and show you how you ought to handle problems with standard forms, and you will never deal with those numbers struggling again. So can I ask you to grab your notebook, grab your pen, and grab a cup of water, okay? And then let's get started. Now, the first thing, again, I would say is to introduce you to the meaning of standard form. Yeah, it's just for you to have an idea of what you're talking about, what you're doing whenever you're talking about or we're talking about standard forms. So standard form means you are writing very big number or very small number in a more convenient way. Okay, now on a daily basis, from day to day, when we see numbers like 5, numbers like 3, numbers like 2, numbers like 0.5, they don't really bother us so much because, well, our minds and our brain can quickly curtail these numbers and deal with them. We can multiply them, we can divide them, we can add them because they are not so big. Okay, but when I have numbers that goes large and very big, like if I have this kind of number, that it even becomes very difficult to pronounce what this number is. Okay, now don't look at it as if, well, this is an exaggeration. No, for example, when you think of a very small number, you want to think about, like, you are thinking about numbers like your Avogadro's number. Avogadro's constant is a very large number. Okay, now when you think about all of these, one way or the other, you face them depending on your field of study. We face them on a daily basis. Okay, so you must learn how to deal with it. So the first thing, again, I said is standard forms is a useful way of writing very big number or very small number in a more convenient way. So if we have this, at the end of this lesson, you're actually going to be able to write this number in standard form. And if we have a very small number, like small numbers goes from 0.0000000, let's say 56. It's a very small number. Okay, so we have to see how we ought to write this. So that is the first thing I have to say. Now, again, for you to know is that numbers like this, numbers like 5 can also be written, even though it's not necessary, it's not going to bother us. However, any number can be written in standard forms. Any number, again, any number, that very big or very small, or just a big number or just a small number, any number can actually be written in standard form. So again, let's look further into the definition. Now, a number that is written in standard form will always have this form. And permit me to use this because this is what you will find commonly in your textbook. So a number written in standard form is written in this format, where you have a multiplied by 10 to the power of n. So if you write a number in standard forms, that number will be written with, 10 must be included. The number must be multiplying 10 to some powers. We don't know what the power is. The power will depend on what type of number you are dealing with. I believe that you understand that now. So if you want to write a number in standard form, you first have to put this in mind. The number you are going to write in standard form is going to look like this. Okay, so now the next thing is for you to understand what each of these numbers mean. Okay, now just take it one at a time. Don't get your mind boggled up. Just follow me one step at a time. Now, the next thing is for you to know, okay, how do I determine my number as A, and how do I know if the number what will be n? Okay, so let me first start with n. This number is just the number of places the decimal point moves, and I'm going to be showing you that right away. So n is telling you about the decimal point. How many times are you moving the decimal point? If you move the decimal point 2 times, that means n will be 2. If you move the decimal point 3 times, the value of n will be 3. Now, again, what you are going to see is it can actually be positive or negative. But first, remember, this n is talking about how many times you are moving the decimal point. You see, for example, in this number, you have a decimal point. And in this other number we have here, there is no decimal point. So we're going to come into those steps one after the other. Now, what about this number A? A is a number that must always be between 1 and 10. You get that? So the number A will always be between 1 and 10. Now, when I say between 1 and 10, it means that it can usefully be written this way. We can write it this way and say it this way. Now, don't disturb yourself if you still struggle with inequalities. I'm just going to give you a simple meaning to this. This, when we say is between 1 and 10, we're just saying that the number cannot be equals to 10. It's just a number between 1 to 9. Okay? A can be 1, A can be 2, A can be 3, A can be 4, A can be 5, A can be 6, A can be 7, A can be 8, A can be 9. Again, A can be 1.1, right? 1.2, 5.2, 3.6. It just cannot be 11. It cannot be 20. It cannot be 30. It cannot be 36. It cannot be 100 or anything. It just has to be a number between 1 and 10. Now, if you keep all of these things that I've said so far in your mind, then you are ready to write numbers in standard forms. So how are we going to do that? Now, let's do that simply. Let's start with the numbers I have written here, and I'm going to give you 3 steps for you to write any numbers in standard form. Now, first, remember, the first step is about the letter A, which is your front number. Again, I call this A your front number, the number that is meant to be in front. The front number must always be between 1 and 10. Okay, the front numbers must always be between 1 and 10. That is, A must be between 1. I'm going to write it in standard forms so that can be easy. I'm going to write it using inequalities so that can be easy. So A must be between 1 and 10. It cannot be greater than 10. Remember, it can not also be lesser than 1. Remember that, please. it cannot be lesser than 1, and it cannot be greater than 10. And the power of 10, which is n, right? N is alpha, or how many times you have moved the decimal point. How many times the decimal point is moving, that's your n. Okay, now the third one, which is the third rule that you have to learn, is if it is a big number, like the one we have here, if it is a big number, then n will be positive. If it is a small number, like what we have here, then n will be negative. If you can take this in step by step, you have learned how to write any number in standard form. Okay, let's practicalize it. Now, I'm going to reduce this to make it very easy for us to first deal with. So I'll start with, let's say 56,000. If you're going to write 56,000 in standard forms, we have said your front number must be between 1 and 10. Now, when you look at this number in front, this is 56. So for this number to be between 1 and 10, it has to be 5.6, right? So that means, remember, there is no decimal point anywhere in this number. So when you have a number like this, you must know that the decimal point is actually at the end of the last number. And you're going to start to move it. Now, when you move 1, 2, 3, 4. So since we moved the number 4 times, it means n is equals to 4. And is n going to be positive or negative? It's going to be positive. Why? Because 56,000 is a big number. So how do you write that? Remember, the front number is going to be 5.6. So now you're writing it like this form. So it's going to be 5.6 multiplied by 10. How many times? 4. 5.6 times 10 raised to the power 4. Do you see it? That's how easy it is. Okay, let's do another one. Let's do another one. We're going to increase the number of zeros we have there. So the other time, so I'm going to make this like 56 million. Right? If we have 56 million, again, there is no decimal point anywhere in this number. So I have to first come back that my front number, which is A, has to be a number that is between 1 and 10. So if this number is going to be between 1 and 10, then again, it has to be 5.6. So I'm going to move it 1, 2, 3, 4, 5, 6, and 7. Excellent. So that is 5.6. My n is 7, and it is positive because it is a big number. 5.6 times 10 to the power of 7. All right, so can you try this? Can you try this? We're still working together. So can I ask you to try this? I'm going to make it 56 billion, okay? So can you try this? Pause the video right now and then see how you can make an attempt on that. So I'm sure you did it correctly, right? So you had 56 billion. So again, the decimal points, you keep moving it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is 5.6 times 10 raised to the power 10. Well done. So you can mark yourself correct. And if you have made a mistake, again, can you correct yourself and keep learning? Don't give up on it. So we still look at more examples. Now, let's keep looking at different examples to help us handle this. Now, imagine you have, I'm still going to try now with small numbers. We've been dealing with very big numbers. So let's try with small numbers. Imagine we just have 0.000000000056. Now, this is a small number. The same rule applies. The only difference here is you remember when your n is positive and when your n should be negative. And when is your n positive? Again, good. Your n is always positive if the number is very big. And your n will always be negative if the number is small. Okay, now when I say small, I mean any number that is lesser than 1. So that is very, very important. That is very important. I'm not saying, just because we have 1 and then you have 2,000 and then you think, well, 1 is very small then. And no, I'm talking about numbers that are smaller than 1. And you start to think about them, they have to be written in this format, right? Not with this lot of zeros, but when you have something like 0.5, you have something like 0.05, all in this format, they are small numbers, okay? And numbers that are greater than 1, from 1 upward, they are big numbers, and the power of n will always be positive. So again, for this question, let's go on. Now, remember your front number, which is here, right, should be between 1 and 10. And if that is going to happen, that means the decimal point must come in between 5 and 6. So I will move this backward. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the last one, 10. So to write this number, we're going to write 5.6 times 10 raised to power minus 10, negative 10. So that's the way to write a small number. So you see, the difference is the same step. You only have to pay attention to when the number is so small and when the number is big. Okay, so can I ask you to try this again? Can you try to write 35600 in standard form? That's the first one. And you're also going to write 0.0000623 in standard form. And let me give you the third one. And the third one, I should just give you 0.003 in standard form. So can you quickly do that? Remember to pause the video and then give that a try. Right, good. If you have done that, so can we compare? Let's compare notes. Okay. Now for the first one, we go 1, 2, 3, 4, and that is 3. Do you see? I had to come in between 3 because that's where you can have it. So we have 3.56 times 10 raised to the power of 4, right? Move 4 times. So look at the second one. We're coming, remember, we cannot come behind this. That would be too great a number, and that's greater than 10. So it has to be between 6 and 23. So it's going to come in between 6 and 2. So we move the decimal point, and this is a small number. So we go 1, 2, 3, 4, 5. So that is 6.23 times 10 raised to the power of negative 5. And of course, this is also a very small number. So we go 1 and 2. Where should we stop? Can we stop here? Remember, if you stop here, it's going to be between 0 and 3. That's why I gave you this. This is, and it has to be, your front number has to be between 1 and 10. So for it to be between 1 and 10, we have to go behind 3. Okay, so 1, 2, 3. And that will be 3 times 10 raised to the power of negative 3. Now, you may want to practice more. You can just give yourself more practice if you have 0.5, right? And we want to write this in standard forms. So this has to come again. We're going once out. Once. That's 5. Look. So it's going to be 5 multiplied by 10 to the power of negative 1, because the decimal point only moved once. Think about it again. If you have 0.000006, okay, 6, the front number must be between 1 and 10. So when I'm moving this, I have to move 1, 2, 3, 4, 5. I can't stop here because this is 0.6. That's lesser than 1. So I have to go behind 6. Okay, 1, 2, 3, 4, 5, 6. And that will be 6 multiplied by 10 to the power of negative 6. So now this is how to write any number in standard form. To write any number in standard form. So what is the next task? The next task is for me to teach you how to write a number that is already in standard form, how to write it in ordinary form. Okay, so you are learning new thing now. Any number that is written in this form, we call that the ordinary form. Okay, and of course, all the ones that are written like this are called standard form. Either it's a large number or small number. If it is written in this form, this is the ordinary form. Now, we want to see if you are given a question or a problem like this, how do you change it back to something like this? Okay, you can take a pause here to put into mind what you have learned and practice over and over again. Okay, and then you can come back and continue the video from where you stop. You just have to track the time. Okay, I stopped at 22 minutes, so I will just come back and continue what I'm learning. So that way you'll be able to take what you've learned, you'll be able to soak it in, all right, and drink some water. Now, what I'm going to do in this section is I'm going to use a different example to write a number that's already in standard form, and then I'm going to take it to the ordinary form. So what will be your classwork is all the examples we've done previously, right? You're going to rewrite them in the ordinary form. Okay, so that's going to help you to check now if you're getting it right. Now, let's use a different example. For example, if I have 4.95 to the power of multiplied by 10 to the power of negative 3. And the question says for me to write it as a ordinary number. So it's like, it's going to be like, write 4.95 times 10 to the power of negative 3 as an ordinary number. Now, what do you do in this case? What do you do in this case? The first thing is, remember, you have to start, for me, and that's a good way to start, is to first look at what type of number are you dealing with. Is it a large number or a small number? Now, since the power here, the power of 10 is negative, I know it's a small number. It's a small number. So you know that the decimal point has actually moved 3 times. Okay, the decimal point has actually moved 3 times. So if you want to take that, if we write that number out again, 4.95, and this, your n, which is the power here, gives you the information about how many times as the decimal point moves. So in this case, we want to return the decimal point. So we're moving it how many times? 3 times. And since it's a small number, we're going to the left. So we go 1, 2, and 3. Now, for all those points, remember your decimal point is now here, right? We have moved this decimal point from this point. We moved it to this point, 1, and then 2, and 3. So the decimal point is here. Now, for every other point, I'm going to put zeros, right? Zeros. And I cannot leave the decimal point open, so there will be a 0 in front. So a good way is 4.95 times 10 to the power of -3 is the same thing as 0.00495. That's it. Yeah, that's it. That's how simple it is. Yeah. Okay, look at this. Look at this. I'm still going to deal with small numbers. Now, imagine if I have 5.6 times 10 raised to the power of negative, let's start with negative, maybe 6, -6. Now, what's this telling me? This decimal point has moved 6 times. And it's a very small number. It's a very small number because the power is negative. So I have to keep moving this to where? I have to keep moving it to the left. How many times? 6 times. So if you move that, you get 1, 2, 3, 4, 5, and 6. So the 6 points is where you have your decimal point. So you have 0, 0, 0. 0, 0. I cannot leave my decimal point open, so there will be 1 0. So this is the same thing as 0.0000056. Okay, you can check. You can always check when you move it. 1, when you go again, 1, 2, 3, 4, 5, 6. So that's how to check for it. Now, what if it's a very large number? What if it's a large number? Say you have 9.5 times 10 to the power of 8. Now, in this case, this is a very large number. How do I know? Because the power of 10 is actually positive. It's positive. It's not negative. So I know it's a large number. So in this case, I'm going to be going towards the right-hand side. I'm going towards the right. And if I do that, that is saying you have 9.5, and then I'm going 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So put the zeros, 1, 2, 3, 4, 5, 6, 7. Remember, this is where the decimal point is. And if you like, you can put 0 behind, but it doesn't matter because 0 after the decimal point does not count. So it's different for small numbers, okay? It's different for some small numbers. So yeah, we have 9, 5, 0, 0, 0, 0, 0, 0, 0. And we said to just write this, it doesn't matter. If you write it like this, you still get your full mark, but it's immaterial. It's immaterial. So that's the way it works. So can you try it for all the exercises, all the examples and the exercises you've done? And if you've done that, you can also check with all of this. You can also add this to it, write all of this in ordinary forms. 2.7 to the power of 2.7 multiplied by 10 to the power of 5. And the second one should be 3.6 times 10 to the power of 8. And the third one should be 5.6 times 10 to the power of, let's say, -6. -6. Yeah, this will be a okay, will be, let me change that. I've had 5.6 to the power of minus 6. So I'll just give you something more simple, not too bothering. Let's say to the power of minus 2. So can you ensure you practice all of this and remember to leave a comment, say something, write a comment, and let me know how far you're doing. And if you still need help with something that I have not covered, or you want me to clarify something, then please do let me know by writing a comment. Thank you. Now we're going to be moving on to, now that you know how to write numbers in standard form and you also know how to write it in ordinary forms, we're going to now move to how to multiply and divide numbers in standard forms. Okay, again, remember you can pause the video right here and just take a breath, walk around, relax. Then you come back and continue the section. So that way you would be able to assimilate a lot more. Okay, so you can just pause and take the piece of information you are getting one at a time so it doesn't become overload, right? So I don't want you to be overloaded. Take a pause, go take a rest, just walk around, then come back. Then let's continue to learn together. All right. It's very important for us to learn how to multiply and divide numbers in standard form. Remember, we're also going to learn how to add them, how to subtract them, but we want to start with multiplying and dividing. And why is this important is usually when questions wants to test these skills, the question is asking you not to use calculator or not to use your tables to actually simplify what you have. Now, since you will not be allowed to use your calculator or to use four-figure tables as it were, then it's important for you to not only learn to write numbers in standard forms, you also have to learn how to multiply and divide numbers in standard forms. So now since we've learned how to write numbers, we can just keep moving to the examples. And when I start to use this example, I'm going to give you 3 steps for you to do this always. Now, imagine if a question says for you to find the value of, say, 2 times 10 raised to the power of 3 and multiplied by 6 times 10 to the power of 5. Now, someone may say, well, we just open it. Now, usually when you have a question like this, it says you should find this. The question will still state that you should leave your answer in standard form. Now, how do we go about this? A very simple step to follow. The first one is to rearrange what you are given so that you put the front numbers and the powers together. Now, I believe you know what I mean when I say front numbers. These are your front numbers. 2 is a front number and 6 is a front number. Now, note first, here, please pay attention to that. We have multiplication. We are actually multiplying, right? And since I'm multiplying these things together, what I should do is to first rearrange these numbers in such a way that the front numbers we go together, they are standing together, and the powers, that is the powers of things, are also standing together. Now, you are now going to multiply, okay? You're going to multiply the front numbers together. So let's first take them one after the other. Now, in this case, I will take 2 and then multiply by, I will take 6, since what I have between them is multiplication. So please note that. 2 multiplied by 6, and then 10 to the power of 3 multiplied by 10 to the power of 5. So what is 2 if you've done this arrangement, the next thing is for you to go on straight up into multiplying and simplifying what you have. So you are going to multiply the front numbers together, 2 times 6, and that will give you 12. Now you have to use the power rule to deal with the powers of 10. And what does the power rule state? The power rule is saying that if you have a number which is the same and they are multiplying each other, then you should add their powers together. So I have 10 and 10 here, and it is multiplication. Then I have to add their powers together. So that would be the same thing as 12 multiplied by 10 raised to the power of, what is 3 plus 5? 3 plus 5 is actually 8. Okay, so I now have 12, and I can take that step by step for you to keep memory of the steps. So I have 3 plus 5. So now I have 12 multiplied by 10 to the power of 8. Now, am I going to leave my answer like this? Absolutely no. Now, notice this, that if you are to be writing a test and I want to mark this, of course, there will be a mark for you to get from here to this point, and from here to this point, you get marks. However, you mix the mark for the final answer because you have not completed it. Why? Good. If you answered the question correctly, the why is because 12 is a number greater than 10. Remember, when we started, we said the number written in standard form should be written in this form, and that A is a number between 1 and 10. And it means that the number cannot be greater or equals to 10. So that means you have to write 12 in standard form. So if you are going to write 12 in standard form, 12 is a big number, of course. So that means n is going to be positive. So if you do that, that will be, you move the decimal point once in between 1 and 2. Okay, so that will be 1.2 times 10 to the power of 1. So I'll come back here and say 1.2 multiplied by 10 to the power of 1 multiplied by 10 to the power of 8. Again, this is another thing I've seen. There is 10, there is 10, and multiplication, then I have to add their powers. So we have 1.2 multiplied by 10 to the power of 1 plus 8. And that is 1.2 multiplied by 10 to the power of 9. Is that good? Yeah. Don't be afraid. Again, if you are feeling too overloaded, you can just take a break. You can take a break right here and then come back. I'm still going to have you with, I'm going to give you another examples we're going to do together. And I can tell you that after that example, you're going to become more confident with this, okay? So welcome back. Now let's look at another example that's going to really be helpful. That would be helpful. So imagine if you have 2 times 10 to the power of 5. We're still looking at how to multiply. Multiplying 4 times 10 to the power of 10. And you have also been asked to do the same thing to find or simplify this or find the value of this in standard forms. So again, the first thing is to arrange these numbers in such a way that the front numbers will breathe together. The front number here is 2, the front number here is 4. So I'm going to arrange that for the two of them to be together. So I will have 2 multiplied by 4. Is that good? Yes. 2 multiplied by 4 and 10 to the power of 5 multiplied by 10 to the power of 10. Now, what's the next step? The next step is to do your multiplication. You have to multiply the front numbers together. 2 times 4, and that is 8. Multiplying, now remember, these are powers. It's 10 to the power of 5 and 10 to the power of 10. So I have to deal with them using the power rule. The power rule says if the same number is multiplying each other, then you should add their powers together. So 10 to the power of 5 multiplying 10 to the power of 10 is the same thing as 10 to the power of 5 plus 10. So this is 8 multiplied by 10 to the power of 15. Now, you see, the answer we have here is actually different from what we had here. Here we got 12, and we had to do another extra step of writing 12 in standard forms. However, here we have 8, and 8 is just a number between 1 and 10. So we're going to stop there. So if you are more happy with this, then I'm so glad. And I'm just going to give you another classwork for you to do. And when you have done that, then you can come back and come and have a look at what we would have together. All right, so while you still take your time to think about what you've done, I will just put that up for you. All right, so good. Now, what's the questions I want to give you? I want you to solve this. If you have 2.8 times 10 to the power of 4 and multiplying 6.6 times 10 to the power of 4. So can you quickly solve this and then come back and tell me what you had? Now, if you have done that, can you pause the video? And if you have paused the video like we usually do, then let's see the solution to this together. Your 2.8 multiplied by that now will be more faster because I believe you are getting used to it. However, being faster doesn't mean we're going to miss any step. So we're going to do 2.8. We're putting the front numbers together. 2.8 multiplying 6.6, okay? And then we're putting this powers of 10 together. 10 to the power of 4 multiplying 10 to the power of 4. Now, what do? Here you have a multiplication to do. You have 2.8 multiplying 6.6. So there are two ways to do that. You just use this method where first you forget about the decimal point and do your multiplication. 6 times 8, and you can have 48 and do all of those together. Whatever method is very convenient for you, can you quickly use that? And then let me see what you have. You can leave your answer in the comment section. Okay, so for me, it's easy to deal with multiplications like this. You just do 6 times all of this, 6 times 28. And if you do 6 times 28, that should be 6 times 8, 48, and 6 times 2, that's 12, and that should give you 168. Okay, that's an easier way to do it. You use 6 to multiply 28. And you said 6 times 8, that's 48. And 6 times 2, that's 12. 12 plus 4 will give you 16. And then you do 60, use 60 to multiply what you have. And if you think about that, it's still the same 6. It's just going to add one more 0 to that. So we're going to have 618. And we can add all of these together. Sorry. We can add all of this together. And if we had all of that together, we're going to have 10861, and this will be 8. This will be what? Good. This will be 4, and that will be 7. That will be 8 and 1. So this is 1848. Now, how many numbers do we have after decimal point? We have one number here and one number here. So that makes 2. So this will be, you count two numbers, 1, 2, and then you put your decimal point. And that is saying what we have here is 18.48 multiplied by, again, we are using the power rule. So this will be 10 to the power 4 plus 4, and 18.48 multiplied by 10 to the power of 8. Now, again, you remember that 18 is a number greater than 10. So what do? We have to write 18 in standard form. So if we do that, that will be moving the decimal point to ones in between 1 and 8. That's 1.848 times 10 to the power of 1 multiplied by 10 to the power of 8. So we have 1.848 times 10 raised to the power of 1 plus 8, and 1.848 times 10 raised to the power of 9. Well done. Again, remember, you can pause the video here, not to overload yourself. Just think about it. Think about the step one after the other. See how you're doing. You're doing great. If you have followed the lesson up until this point, you're doing so great. And you are really committed to learning. So don't pull back, okay? Don't pull back. Just let me know how far you're doing, what you want me to do more, what you want me to explain. And that is going to go a long way in helping me to make more content that is suiting my viewers, all right? So enough about multiplication. Can we move a little bit further to division? So I'm going to be using something similar to what we've seen before. So if we have 2 to the power of 5 and divided by 4 times 10 to the power of 10. Now, sometimes in some, it depends on the kind of test you're taking, you could have it written this way: 2 times 10 raised to the power of 5 divided by 4 times 10 to the power of 10. It's still the same thing, please. It's still the same thing. That means if you have the questions in this form, you can actually write it this way. And if you're more, whatever form you feel comfortable with, but because I want you to be familiar with a simple step that you can use more often to deal with problems like this. So I will always be going with this. So if I have a question written this way, I will change it to this form, right? Which is still the same thing. Now we're going to the same step. And what's the step? The step is we're going to put the front numbers together, taking note of the division sign this time. So here we're going to have 2 divided by 4. And now you say, well, we have multiplication here. Yeah, the multiplication is between 2 and 10, okay? And this division is between everything. So that's the difference. So we have 2 divided by 4, okay? And what will be the result of that? 2 divided by 4 multiplying. Remember, we also have multiplication. Multiplying 10 to the power of 5 divided by 10 to the power of 10. Now, don't get confused. I can also show you using this. I can show you using this. Now, these are the front numbers. So you can break it down and say this is 2 divided by 4. Now, multiplication, we just take one of the multiplication sign as 10 to the power of 5 divided by 10 to the power of 10. Both of them are the same. And I can see you're probably thinking this one is better. Whichever is better for you, you go for it, right? You're just going to be following the same step. Put the front numbers together to do the division and the powers together to also do the division. Then you can put the sign beside them. Now, when you see 2 divided by 4, don't get confused. 2 divided by 4 is different from 4 divided by 2. Okay, 4 divided by 2 is 2. 2 divided by 4 is 0.5. And now multiplied by, what do we have here? Now, earlier is multiplication, now is division. So the law of power says if the same number is dividing each other and they have power, now you know what to do. We're going to subtract. So that is 10 to the power of 5, take away 10. And if you're also using this method, is 2 divided by 4, and that will be 0.5, multiplied by 10 to the power of 5 dividing 10 to the power of 10. Just let me know in the comment section if you actually struggle with powers of numbers. I can make a series on powers of number later on. But if you are not struggling with that, then keep moving forward. Okay, you're doing so well. I appreciate you. If you have moved, if you have gotten to this point, you have really done well. Okay, so I have 10 to the power of 5 dividing 10 to the power of 10. It's still the same law of power. So I'm going to take away, it's going to be 10 to the power of 5, take away 10 to the power of 10, that's 10. So, and look at this, 5 take away 10 is different from 10 take away 5. If you have 10 take away 5, that will give you 5. When you have 5 take away 10, that will give you negative 5. Negative 5. Okay, so the same thing here is 0.5 times 10 to the power of negative 5. Now, the last thing is, you know that these numbers, 0.5 cannot be allowed because it's not a number between 0 and 1. It's not a number between 10 and 1 and 10. 1 and 10. This is a number lesser than 1, so I still have to write 0.5 in standard form. And how do you write 0.5 in standard form? I'm just going to move the decimal point once. And you remember 0.5 is a small number. Okay, so that is 5 times 10 to the power of negative 1. 5 times 10 to the power of negative 1. So 5 times 10 to the power of negative 1 times 10 to the power of negative 5. Now we have come again to the power rule for products. And since it's multiplication, it says that we should add their powers. Negative 1 plus and minus negative 5. I like to always put a bracket in between those to give me an understanding. So what does that mean? This is the same thing as 5 multiplied by 10, negative 1, and negative 5. That is negative 1 because a positive number multiplying a negative number is going to be negative. So we have 5 times 10 to the power of negative 1 and negative 5. And that will give us 5 times negative 1, negative 5 will give us a negative of 6. And that is what is required of you. That is what is required of you. Okay, so that's how easy it is for you to deal with all of multiplying and dividing numbers in standard forms. Now, let me give you some quick quiz to check what you've been learning so far. Can you write these in ordinary form? 4.32 times 10 raised to the power of 8. You write it as an ordinary number. And you can write 0.000387 in standard form. And finally, I will ask you to check, even though it's not a content I've covered now, but can you check which of these is the smallest number? 2.6 times 10 raised to the power of minus 3 and 1.9 times 10 raised to the power of negative 3. And finally, 3.4 times 10 raised to the power of negative 2. So which of this number is actually the smallest? Okay, the smallest. Now, and the fourth one would be 9 times 10 to the power of 7 divided by 3 times 10 to the power of 4. And finally, the last one is 6.7 times 10 raised to the power of 10 multiplied by 4.8 times 10 to the power of 10. So can you try your hands on all of these questions? Remember, here you're doing which is the smallest. And here you're finding the values like you have there. So remember to leave your answer in the comment section. And if you struggle with any, let me know, then I'll be able to cover this. So finally, on this episode, let's see how you should add and subtract numbers in standard forms. So imagine you had 2.8 multiplied by 10.4 and it's being added to 6.6 multiplied by 10.4. Remember, it's the same step. Okay? If you are adding numbers, the only thing you have to think about, which is really going to help you, well, I have done that with this question, and I'm going to show you in another question how you should go about that, is if the powers of 10, the powers of 10, if they are not the same, it's actually difficult to be able to deal with problems like this. So the first thing you want to do when adding numbers or subtracting numbers in standard form is you want to ensure that the powers of 10 are the same. So that, for example, in this, we have 10 to the power 4 and 10 to the power 4. They are the same. Now, if they are the same, what should you do? The next thing is for you to add or subtract the front number. If it is subtraction, you do the subtraction. But if it is addition, you just add them together. Okay? And afterward is, if the answer needs to be converted to decimal, to standard form, you have to do that like we've been doing before now. So another way to look at this is going to be that if I want to deal with this is, if the powers are the same, 10 to the power 4 is what is here, 10 to the power 4 is what is here, I can factor it out. And when I take it out, I'm having 2.8. Remember, 10.4, 10 to the power 4 is already out. So I have 2.8 plus. Here too, I have 10.4, so it's already out there. So 6.6. And then I close the bracket such that the bracket can multiply 10 to the power 4 times 2.8, and we have 2.8 times 10 to the power 4. 6.8 times 10 to the power 4 will give me 6.6 times 10 to the power 4. Do you see that? That's why it's important for you to have the power of 4 to be the same. So the next thing is to add these numbers together. So 2.8, add 6.6 to that, and this will be what? 4, of course. And then you come with your decimal point, and this is 8, and that is what? 9. So that is 9.4. 9.4. So the addition of what is in the bracket is 9.4. So I have 9.4 times 10 to the power of 4. And 9.4 is a number between 1 and 10, so I'm free. So this is how to deal with any number in standard form. Now, the next thing to do is to look for different questions that is testing your understanding on how to deal with standard forms. Thank you, and then I will see you in the next series. Remember to comment and subscribe. Thank you.